In this chapter, we are going to be talking about hypothesis testing. This is one of the most important ideas that we are going to cover in this course. And it's an idea that we're going to come back to over and over again for the rest of the semester. So it's important that we really get this idea down. And it can be a little bit of a complicated idea. There's a lot of details that go into a proper hypothesis test. So before we get lost in all those little details, I want to kind of focus on the big idea. And that's going to be the focus of this section. We are going to focus on the main idea of a hypothesis test. Okay? To motivate the discussion, I want to focus on an example. So say we have a great big box, and in this box are 10,000 marbles. And I tell you that in this box there is exactly one of those 10,000 marbles that is white. So there is one marble that is white. And then the other marbles, all the other marbles are black. So that's 9,999 marbles that are black. And I ask you to reach in your hand into the box and without looking, randomly select a marble. Okay, so you close your eyes, you reach into the box, move all the marbles around, make sure they're good mixed up, and you pull one marble out of the box. And it's white. Okay, so what does that mean? There's a couple of possibilities. If you pull out a white marble, possibility one is you are extremely lucky. There was only one white marble out of all those 10,000 marbles. And you managed to pick it. Well done. Okay? But there's another possibility. Maybe there is more than one white marble. Now, I told you there was only one. But maybe I didn't check carefully. Maybe I lied. Maybe someone else snuck in and put more white marbles in there. Maybe I got the white and the black confused. Maybe there's actually 9,999 white and one black. Okay? So it's possible that I was just wrong. Okay? And there isn't exactly one. So these are what could have happened. If you reach in and you pull out a white marble, these are the two possibilities. These are the two options. And as you think about it, you might say, well, gee whiz, I don't think I'm that lucky. There's a 1 in 10,000 chance that I would get that one white marble. I don't think I'm that lucky. And if you're not that lucky, what does that leave? That means that there is more than one white marble. And so if we look at it based on that evidence, we might conclude, well, gee whiz, I don't think the original claim or the original hypothesis is actually correct. I don't think there's just one white marble. I think there's more than one white marble in that box, based on the evidence, based on the fact that the one time I picked a marble, it was white. Okay? This is the basic idea behind a hypothesis test. So there are 4 basic steps to a hypothesis test, and we'll kind of talk about the foundations. But I want to talk about kind of a pre-step first, step 0. In order to conduct a hypothesis test, the idea is that we will be testing some claim about a population. And we can't survey the entire population. It's too big or too impractical. So we need to gather a sample. Okay, so step 0 is gather a random sample. In this class, generally the sample will have already been gathered first. You'll just be given the sample data. But in real life, the first step for any real statistician is they need to gather their sample data first, and they need to gather it well so that it truly is random and it has the best chance of reflecting the population. Okay, so most of the time in this class we don't have to worry about this. So we'll start with step one. Step one is we need to first decide on our hypothesis. State the hypothesis, or state the claim. This is generally going to be a hypothesis about some parameter of the population. A claim, the hypothesis is a claim about a population parameter. The two parameters that we are going to focus on in this chapter are the mean of a population or the proportion of a population. Okay? Once we have identified the hypothesis that we are interested in testing, we go to step two, which is if we assume the hypothesis is true. Assuming the hypothesis is true, identify the sampling distribution. This will change depending on what our hypothesis is, what parameter we're looking at, right? If we are testing a claim about a population mean, then the sampling distribution we would be interested in is the sampling distribution of all sample means, because the sample mean is a point estimate for the population mean. Okay, so we use the central limit theorem for sample means to identify that sampling distribution. If we are interested in the population proportion, then the sampling distribution that we'd be interested in is the sampling distribution for proportions, because the sample proportion is a point estimate for the population proportion. Okay. Once we have identified the sampling distribution that we're going to use, we need to go to step three. We want to find the probability. And this goes back to step zero. Step zero, remember, we have that sample data. Okay? So we have a sample. So the probability we want to find is the probability that we get a point estimate like the one we have, assuming the null hypothesis is true. Okay? We use the sampling distribution. To calculate the probability of randomly choosing a sample with the point estimate as far from the population parameter, I should say, at least as far as the population parameter, as our actual point estimate is. Okay, so we're just finding the probability that we get the sample that we do. In the above example, okay, we kind of used a more intuitive approach than what we're talking about down here. Down here, we're being very careful about doing this deliberately, right? We identify the sampling distribution, we calculate the actual probability. In this example, we just kind of use our intuition. If we choose that one white marble, assuming the claim is true, assuming the hypothesis is true that there is only one white marble, okay, the probability would be extremely small of actually choosing that, right? And so the fact that we did suggests that maybe the hypothesis we are assuming to be true isn't actually true, okay? So we didn't actually calculate the actual probability, but we know that the probability of choosing that one white marble out of all 10,000 is going to be very small. When we actually get to the problems, we're actually going to calculate the actual probability, not just use intuition, so that we have exact values to work with. Okay? And step 4, once we have that probability represents the probability that we randomly choose a sample. If we randomly choose some sample from our population, then the point estimate from that randomly chosen sample would be at least as far from the population parameter as the point estimate we actually got. We want to know the probability of getting the point estimate we actually do. Okay, if the hypothesis is true, assuming that hypothesis is true. Okay, so step 4, once we have that probability, we need to draw a conclusion. If the probability is very small, if the probability is very small, then we might say, well, gee whiz, this is so unlikely to happen if the hypothesis is true, that instead I think that the hypothesis probably isn't true. So we might choose to reject the hypothesis. If the probability is not very small, we might not feel comfortable rejecting the hypothesis. Okay? So going back to our example up here, if there's only one white marble and I reach in and I pick out that one white marble, okay? If we assume that's true, that probability is very small. And so if there was in fact only one white marble in the box, you are extremely lucky. It is a really unlikely thing to happen, okay? In fact, it's so unlikely, that probability of that happening is so unlikely that instead we say, you know what, I don't think that's true. I think there's more than one white marble in that box, okay? Now say we get a different box, and now say 10%, I tell you 10% of the marbles are white, okay? So that'd be 1,000 of the 10,000. And you do the same thing, you close your eyes, you reach in, you mix the marbles up, you reach in, you grab out a white marble, and it's white again, okay? Now this time, you don't have to be super lucky. It's still unlikely to happen, but there's still a 10% chance that you get that white marble since 10% of the marbles are white. So you don't have to be extremely lucky, you just have to be a little bit lucky. And being a little bit lucky, that happens, right? So you might say, well, you know, I did get this white marble. Maybe there's more white marbles in the box. But it's still very possible that this one white marble I have, I would have drawn it out if 10% of these marbles are white. That's not crazy, right? That's not crazy unusual. So I'm not comfortable in saying there are more white marbles in the box. For now, I'll take your word that 10% of those marbles are white. Okay, so the probability determines a lot. We really need that probability to be very small to be able to reject a claim. Okay, now how small is very small? We will talk about this more in future sections, in which we will focus on determining at what threshold will we be comfortable with rejecting the hypothesis or rejecting the claim. For now, we're just going to use our intuition and feel it out. Do we feel the probability is small enough or do we not to be comfortable rejecting the hypothesis or rejecting the claim?